Good morning, grade 9. Sorry, I think yesterday I said it was Friday. It's not. Today is Friday. Okay, so I'm here working from home, and this is going to be my last video actually for this unit. We are at the end of Unit 1, which is square roots and surface area. So today I'm just going to do what I would think is probably one of the tougher questions from the unit, and then I'm going to set you loose on trying the review and the practice test that's at the back of the textbook. And remember, I gave you link to the PDF copy of the textbook. Okay, so I'm going to try drawing this. And again, remember, this is not art class, so we're not too worried about how we draw this. Okay, so what we have is kind of like one of those dog toys you see, with a little bit of a wonky one, where there's a cylinder in the middle, and then this over here is a rectangular prism, and we know that because its dimensions are 2 5/10 by 1 5/10 by another 1 5/10. So the ends are squares, but this piece here is a rectangle. The neat thing is this piece here happens to be a cube, and I noticed that when I saw the dimensions and saw that all four sides of this face here were exactly the same. Okay, and then it doesn't have the dimensions in the textbook right on the picture, but if you read the question, it says the cylinder is 3 5/10 of a meter long. I guess we should include all the units since I've been nagging about that. And then it says that the diameter of the cylinder is 5/10 of a meter. So we know that that's the whole distance across. So again, we have to cut that in half. So the radius would be half of 5/10, which would be 25/100ths of a meter. Okay, so I'm going to do this a different way today. What we've been doing is we've been subtracting overlap from the formulas before we even get started. But in this case, and this is why I think this question is a little tougher, we have to understand that where this circle meets this rectangular prism, the cylinder, sorry, meets this rectangular prism, there are two circles that are overlap, but it also meets over on this side. So there's two circles over here, which gives us a total overlap of 4 circles. And there are not 4 circles in the formula. So what I'm going to do is I'm going to find the whole surface area of this one. This is just a different strategy, and some of you liked it better. So this is me stepping out of my comfort zone for you guys. Okay, and then what we're going to do is we're going to find the surface area of this rectangular prism, the surface area of this cube, and then we're going to find the surface area of this cylinder. We're going to add that all together, and then we're going to come back and we're going to concentrate on the surface area that these overlaps would have taken off. And what we're going to do is we're going to subtract that from the total. Okay, so I'm going to start with this one, cube A. I usually go left to right, but I like cubes because they're easy. I'm going to call this section B, and then we're going to come back to the cylinder and we're going to call it C. Okay. So A is a cube, and how we find the surface area of a cube is we use the area formula, sides squared, and now we're going to times it by the number of sides, and we're going to do the whole thing this time. So area is going to be 2 5/10 of a meter squared times 6, and remember those are sides if you're wondering where that 6 is coming from. And when we square 2 5/10, we get 6 25/100ths times 6 is equal to 37 5/10 of a meter squared. And I'm going to circle that. That's my strategy. Okay, look, we're a third of the way through this already. B is going to be the rectangular prism. And I know that my formula for that is going to be using length times width. And my strategy is, remember, I do front, back, top, bottom, side, side. Okay, so here we go. The front and the back. The front is 2 5/10 by 1 5/10. And there's 2 of those, and we're going to end up with 7 5/10 of a meter squared. And then the top and the bottom, it turns out we could have done this times 4 because they're exactly the same, but this is my strategy, so I'm going to stay the course. So we get exactly the same answer there. Now we're going to do the sides, and the sides are squares. You can write down length times width, but it's really a side squared. When we do that, we get 4 5/10 of a meter squared. Okay, so we can add this up and do the total surface area of the rectangular prism, or we can just keep circling and know that we're going to add these all together at the end. C is my cylinder. And I remember that the surface area of cylinder is 2 pi r squared plus 2 pi rh. So I'm going to plug that in. 2 times 3 14/100ths is what I use for pi, but you can use the pi button on your calculator. Remember, we determined that The radius was half of the diameter, so we're going to square 25/100ths. 2 times 3. And I mean, have a calculator handy, people. This is where calculators come in handy. All right, so on this side, we're going to get this over here. And so I wrote down that it was close to 5 9/10 of a meter squared. Okay, so then I added this, and then I added this. And the total surface area that I had so far was 62 9/10 of a meter squared, approximately. And now I have to subtract the overlap. So let's go back and let's talk about this again. Okay, I want to make sure everyone understands. Bottom of the cylinder would not be covered, nor would the spot on the cube where the cylinder attached. Bottom of the cylinder not covered, where it attached to the rectangular prism not covered. That's where we get 4 circles. So remember, area of a circle is pi r squared. And how many overlaps did we have? 4. Okay, so this piece here, I'm going to call piece D, and I'm going to label it the overlap. And we've determined that it's circles. So I'm going to plug this in, 4 times pi, and the radius we said was 25/100 squared. And when I work that out, it's a tiny number actually, because we're multiplying by a number less than 1. And I got that it was around, well, when I figured it out on a calculator, this is exactly what I got. And I rounded it to around 8/10. So I subtracted 8/10 of a meter here. Okay, and then my final answer was around 62 1/10 of a meter squared. What I'd like you to do is I'd like you to go back and watch this video one more time, okay? This is what I would call sort of the challenge part of this unit, and if you can follow along and manage that, that is absolutely fantastic, okay? Today is going to be the day where you can text me or shoot me an email or ask questions on the Google Classroom from any of the other work, and today is the day that I want you to spend some time working on the review that is in the textbook. And remember, on the Google Classroom there is a link to the textbook. I'm not a huge fan of the textbook, but we're in certain times, and so what I'm going to do is I'm going to, on the Google Classroom, list the questions that I want you to do, because there's some of them that I don't think are important, and so we're not going to waste our time doing that, right? We're looking forward to grade 10 and those skills that we need to take forward there. So we're going to go back to the beginning of this unit where we're benchmarking square roots and things like that. And that is a really important skill that you're going to take forward into grade 10, Math 10 Foundations Unit 4. That's where you're going to see that again. So I know that you need to be able to do that. Okay, take care. You're not going to hear from me till Monday again now. So I hope you guys have a good weekend. Get outside and get some fresh air. Love you guys.